So this is the frame format for the HDLC. The first field is the flag byte, which indicates beginning of the frame. So the value of the flag byte is 7E, 0, 6, 1s and 0. 7E is the flag byte that is being used to indicate the beginning of the frame, and the same flag byte is used at the end of the frame to indicate this is end of the frame. Okay, again 7E is the flag byte. So this indicates the beginning of the frame, this indicates the end of the frame. Suppose after this we want to send the next frame, again the flag byte of the next frame at the beginning. So the same flag byte of the next frame, this flag byte will come again at this point. In that case, this flag byte indicates end of the current frame, and this flag byte indicates beginning of the next frame. So when you are using the successive number of frames, so one flag byte is not being suppressed, it is being used. So then between two adjacent frames, two flag bytes will be available. Two flag bytes will be appeared. In that first flag byte indicate the end of the first frame. Second flag byte indicate the beginning of the second frame. So please remember all of you. This is what is being happening. So two flag bytes. Then this field is the address field. So is also 1 byte. So this, suppose if sender is sending this frame, then this is the address of the receiver. Okay. If sender is sending this frame, address is receiver. If it is acknowledgement coming from the receiver, then the address is sender's address. Okay. Now, if the sender is the primary, then this address is a secondary address, that is the receiver address. Remember, the address belongs to always receiver in this case. Okay. So in this particular HDLC protocol is using only one address, that is the receiver address. But later we may be coming across the other frame format like Ethernet frame format, where two addresses are available in the frame. A frame will have two addresses. One is the sender address, other is the receiver address. Source address, destination address. Both these addresses are available in that. Okay, so that is in that case. Okay, so but in this particular case HDLC, only one address field is available. So that address indicates a receiver's address. Okay, receiver's address. And the control field indicates what type of frame it is. Okay, we will discuss the control field elaborately later, just as of now. So please remember that this indicates the type of frame. 1 byte is used to indicate the type of frame, control frame. Then the payload, this indicates the data. So whatever data the sender want to send is being kept in this, the variable size. So generally the maximum size of frame is around 1500 bytes. Okay, most of the protocols are supporting this data size of the frame is around 1500 bytes. Okay, so that is, so this particular payload size around 1500 bytes. The next field is frame check sequence, FCS, frame check sequence. So already in the previous classes we have discussed about the CRC mechanism. Okay, that CRC byte is used as the frame check sequence. Same thing is being stored here. Okay, so that at the receiving, after receiving the data will be again computed for the checksum. Then that checksum and this will be compared, whether any mismatch or not. If there is a mismatch, so whatever is received is having some errors. No mismatch, no errors, likewise. For that purpose, so this frame check sequence is being used. Okay, here it is being used either 2 bytes or 4 bytes, but most of these HDLC frame is using 2 bytes. as the frame check sequence, 16-bit frame check sequence. The final field is flag field, flag byte, which is indicating the end of the frame. This indicates the end of the frame. So that is about the different various fields. So now out of this, so this control field we'll see little later, indicates the type of the frame. Okay, what are those types? So already what we have seen, the flag byte indicate the beginning and ending of the frame with the value of the flag byte is 7E. The address contains so the receiver's address. If the sender is the primary, receiver will be the secondary. If the sender is secondary, receiver will be the primary. Okay. So in this case, one or more, receiver can be one or more. If sender is the primary, if the sender is primary, a receiver, this is the receiver address if it is 1-to-1. Suppose if it is a broadcast, if this indicates all ones, if the address field indicates all ones, means is a broadcast address. That information should go to all the receivers, all the secondaries. That is about the address field. So I'm sorry, just a few seconds. Okay, that is about the address field. So if the address field indicates all ones, that indicates the broadcast, means sender is a primary, receiver will be all secondaries will receive. If the sender is a secondary, then this address is a primary address. Just remember that. So that is why, so contains the addresses means all secondaries like a broadcast. Okay. Control field 1 or 2 bytes just indicates type of frame. What type of frame it is, what type of data or what type of frame it is will be indicated by this. That we will see little later. So payload is the data, frame check sequence. Okay. So depending on the control field, the frames are being divided into these 3 types: information frame, supervisory frame, unnumbered frame. Okay. So depending on the control field value, the frames are these 3 types: information frame, supervisory frame, unnumbered frame. We'll see what each one. So the control field size is 1 byte, 8 bits. So based on these 8 bits, how these frames, okay, so remaining part of the frame we are not going to repeat again. Only the control field part of the frame will repeat. Okay, so remaining fields will be as it is for almost all the types except the supervisory. Okay, so first is information frame, means that frame is carrying, whatever payload is carrying is the data from sender to receiver. Okay, information frame is always from sender to receiver. Okay, and the first bit of the control field indicates 0. If the first bit indicates 0 means that is an information frame. If the first bit is 1, then that frame can be either supervisory type or unnumbered type. Okay, so maybe next screen will get it, right? If the first bit of the control field is 0, then it is information frame. Okay, the next 3 bits will indicate frame number that is being sent by the sender. So frame number 0 to 7. Which information, which frame number, sequence number, which frame number the sender is sending to the receiver. So what frame the receiver is receiving is indicated through this sequence number. Is indicating through this sequence number. So for this information frames, so the next one bit PRF, either polling or final. So for the information frame, this bit will be taken as final. Okay, this will be taken as final. So if this final is equal to 1, means this is the last frame the sender is sending to the receiver. After this, receiver is not going to receive any more frames. That is the indication between the sender and receiver for concluding their communication. Okay, to know, receiver will be knowing that this is the last. After this, they can close their communication. They can terminate their communication. They can terminate their connections. So for that purpose, this part, one bit is being used. Okay, this one bit is being used. Right? That is final. And this, the acknowledgement number received from the receiver by the sender, it is indicating with this. That is the use of this next. Okay, so that is about the information frame. Hope everyone understood these various fields. So the sequence is the sequence number to indicate this is, with this help of this, the receiver is able to avoid the duplicates. If the receiver receives the same frame with the same sequence number, multiple frames with the same sequence number, then they will be treated as duplicates. Okay, so to recognize the duplicates, the sequence number, acknowledgement number are being used. So that is about the information frame. Next is supervisory frame. So in control field, the first bit is 1, supervisor are unnumbered. If the first bit is 0, information frame. So first bit is 1, either supervisor or unnumbered, then second bit will come into the picture. If the second bit is 0, then is a supervisory. If the second bit is 1, then it is unnumbered. So that means 1 0 means supervisory. First bit 1, second bit 0, supervisory. First bit 1, second bit 1, unnumbered. First bit 0, information. Okay. So that is about this supervisory. So generally this is coming from the receiver to the sender. Generally the supervisor frames will be coming from receiver to the sender. So what is the use? And total out of 8 bits. So final are polling 1 bit, 3 bits next, and 4 bits are these 1 0 2 bits. The type is 2 bits. Then 4 types. Again, the supervisor frame is 4 types. 4 types of supervisory frame. Type 0. If these 2 bits are 0 0 means type 0 frame. 0 1 type 1. 1 0 type 2. 1 1 type 3 frame. So what is the use of these 4 different types of supervisory frames? Okay, we will see one by one. First is, say type 0 is an acknowledgement. Type 0 is acknowledgement. Suppose if this is 0 0, this indicates acknowledgement. Then this is the frame I am expecting next. Okay, this is the next frame I am expecting. If this value is 0 0, frame 0 I am expecting. If this is 0 0 1, expecting frame 1. If this is 1 1 1, expecting frame 7. Okay, that is the meaning of this next field. So this is the frame the receiver is expecting next time. After receiving this acknowledgement, now the sender has to send this frame. That is the meaning of next. Okay, this acknowledgement, positive acknowledgement. Meaning is positive acknowledgement. So I am expecting this frame. So before this, received okay. That is the meaning of this acknowledgement, type 0. Okay. Next is type 1, go back and. Type 1 is go back and. So if 0 1 means type 1, go back and means from here onwards, retransmit again. If this is a 0 0 1, so frame 1 onwards you have to retransmit. Already we have seen the go back and. Okay, the same concept. So from this frame onwards, you have to retransmit. I am rejecting from this frame onwards. So you have to send from this frame onwards again. That's the meaning of this. Okay, go back and if type 1 is there, go back and so from this frame onwards, the sender has to retransmit again. That is go back and. Third, 1 0. 1 0. So 1 0 means receiver is not ready. Maybe sender is sending one after the other. Suppose I am the receiver. I am keep on receiving. So in between, due to some reason, I could not able to receive. I was busy with some other task. So I missed a particular frame. I could not receive. Then I will include this. Receiver not ready. Type 2. Then I have not received this frame. Okay. Due to some other reasons, I could not receive the frame. I'm not saying that is having errors. Okay, I could not able to receive it due to some reasons. So I was not ready. I was not ready to receive this frame. So I could not receive this. Send me this. That is type 2. Type 3. Type 3. 1 1. Type 3 indicates selective repeat or selective reject. So in the previous what we have seen, maybe frame 2 is rejected, all other are accepted in the selective repeat. Only 2 is rejected. So retransmission for 2 only. Same thing can be reported at this. Next. So type 3 means selective reject or selective repeat. So this frame only I have not received properly. Only send me this. Okay. Whatever you sent after this, you need not send now. Only this I want again. That is the meaning of this. Okay. That is the meaning of this. Got my point? So that is supervisory frame. So 4 types. Type 0 acknowledgement. So I am expecting this. Type 1 go back. From this onwards I need again. Type 2. So not received. Please send this. Type 3. Select to repeat or reject. Only this I did not receive correctly. All remaining okay. So please send me this again. That is the meaning of this. Hope everyone understood. Okay, that is about the meaning. So final polling. So generally if it is information, so final. Polling means the secondary, primary will ask the secondaries. Is anyone want to participate in the communication? Okay, the sequence number is the ID. Address part. Okay, so polling, right? That is generally will be taken care in the unnumbered. So next is unnumbered frame. Management frames. System management frames. Okay, system management frame. See, first 2 bits are 1 1. If first bit 0, information frame. First bit 1, second 0, supervisor frame. First 2 bits 1 1, unnumbered frame. Okay, so here this can be used if supervisor is asking about other secondaries. Is there anyone want to participate in the communication? Then polling. Then it is being used as polling. Then this will be used as the address. So information, whether anybody wants to communicate, participate in the communication, want to send the frames or want to receive the frames, depending on what type of information, what type of communication they want, that they can include in this. So likewise, these are the different types of frames that are being used by the HDLC protocol.